Hello everyone. This is part 2 of our review for unit test number 2, and we left off with question 6 to complete, and this particular question involves what we call literal equations. So instead of solving for a value of x or being given values for the variables and solving for the unknown, we have to solve for one of the variables in terms of the other variables. So algebraically, I'm going to show this two ways, algebraically and mentally arguing. If you start with this equation, V equals PQR, realize there's only really two major operations. Multiplication or division is one of them. Those are inverses of each other, or addition and subtraction are inverses of each other. So those pairs are the only real two operations we use. And so we just have to undo what's happening between the variable that we're solving for and the other variables involved in the equation. So with regards to solving this formula for Q, we understand that P and R are being multiplied by the Q, and to undo multiplication, we divide. So the way that we could show that literally, and that's why we call these literal equations, is to rewrite PQR and divide by the P and the R. So therefore, the V gets divided by the P and the R as well. And so the P's and the R's cancel on the right. You don't need to show this, but if you did, these guys cancel, replaced by ones, right? We don't really need to show that. But notice that all we're left with is 1Q over 1Q, or just simply Q. And that equals, in terms of the variables, V over PR. So you could show it literally, or you could just do it mentally. Thinking about it mentally, if you start with V equals PQR, I'll just explain in words what we're going to do, or what we're going to undo. We're going to undo the multiplication of P and R by the Q, so we're literally just simply going to divide by PR. And if you don't like to show it like we showed algebraically here, then you can just take the V, divide it by the PR, and that's going to give you the Q. So if you want to do it mentally, that's great. Okay, the next question is another literal equation. And this involves basically two steps. We want to solve for R in this formula. And I'm going to recopy the equation here. A equals B plus BRT. I make my R slightly different than the way it's typed. And if I want to get at this R, that's ultimately what I want to do, is solve for this R. You can think that the last step's going to be that division, just like we divided by P and R in the last example. We're going to divide by B and T in this example. But before we do that, we have to get rid of this B. We have to isolate the term containing R. So we're going to transpose the B, and this is showing it algebraically, by subtracting B from both sides. Now on the left, this is what may seem awkward to students. There's no combination, there's nothing we can do with this, A minus B. We literally just have to rewrite it as it is, A minus B. Line up the equals, these B's are gone, and then we bring down the BRT. And then, just like the last equation, to get rid of the B and the T, we're going to divide. So the BRT is going to be divided by the B and the T, because we want the R and the B and the T are being multiplied. So this A minus B also gets divided by the B and the T. So then what we have is that a minus b over bt is equal to r. Now, again, if you want to do it mentally, because some students, I think, might actually like the concept mentally, just kind of explaining in words what we're doing. I mean, you don't have to explain in words, you could just do it. But the idea was first subtract the b, this b, not this b because it's being multiplied. So this b subtracted gives a minus b equals brt. And then the second step would be to divide by bt. So we get a minus b over bt is equal to r. Okay, so practice that one because you'll see something really similar. And then we get into more board problems. This one tells us the area of a rectangular sign is 4,104 square feet, and it gives the width to be 57 feet to know the height. So you might make a sketch. It's a rectangular sign, so there's my rectangle. I'm given the width here is 57 feet, but the length I don't know, that's question mark. And we're given the actual area. So if you want to shade it in, that's fine. But this area is given to be 4,104 square feet, or remember we can indicate it by feet with a superscript of 2. Feet squared or square feet. And so when dealing with a rectangle and its area, you have to memorize this formula. Area is L times W, length times width. And basically, once you've established that, then it's just like the previous questions where we had to solve for the unknown variable by making a substitution with the given values of the other variables. In other words, in this case, we're given the area as 4,104, so we substitute that. You could drop the units, and it's equal to the length that we're looking for times the width, and we'll put the width in parentheses to indicate multiplication, because what's happening between the L and the W is multiplication. And so then we'll substitute the width of 57. And you could solve that by just dividing by 57 right away. I'm going to take the time to rewrite it, just show it more explicitly. That is, I prefer, instead of having, I keep on writing 40, instead of having L57, it's better to have 57L, right? But then we're just going to divide. And we're just dividing by the 57. And that gives us, okay, obviously use a calculator here. So 4,104 divided by 57 is 72. And remember, the dimensions of length or width are linear, one-dimensional, so feet. And that's what L is equal to. Okay, next question looks really cumbersome, but it's one of the easiest questions on the exam. We saw this in the lecture as well. Very similar example. This person, Dolbear, has a law where he could predict the temperature of that it is outside based on the rate of the chirps of these snowy tree crickets. It's kind of interesting. So as the number of chirps increase, looks like temperature is increasing as well. And so this is the formula. So T equals, I'm going to recopy it, you don't have to, 50 plus n minus 40 over 4, where n is the number of chirps per minute. So we're asked to just find the temperature T. So it says find the temperature. So basically we're asked T is question mark when the number of chirps, or n, is 94. So this is just a basic substitution. And we're only substituting the one variable, n. So T is what we're looking for. Recopy 50 plus n was 94 minus 40 over 4. Now, I might just suggest one thing here in terms of the computations. Calculate 94 minus 40 over 4 separately. Make sure you press equals after you do the subtraction in the numerator. So 94 minus 40 equals 54, and then I'm going to divide that by 4, and it gives 13.5. And then add that. So it's probably going to be less risk for error if you just do this computation separate and then add it. So we get 63.5, and formally degrees Fahrenheit, so Fahrenheit degrees. Okay, so then we get to the last stage of the course, which is just inequalities. There's going to be one question where you just graph the inequality. You earn 5 points for just doing this. And remember, we draw the number line. You could use 0 as a reference. Locate what I like to call the critical value, -3, somewhere to the left. You don't have to put it to scale, just simply on the correct side of 0. And remember that this is read as greater than or equal to, and equal to means we include the endpoint, and we indicate that on the graph with a solid circle. If it's just greater than, would be an open circle, not including the endpoint. And then greater than, remember, is everything to the right. So we're just going to shade in a line to the right of that, and that's our graph. And I think in my math lab they actually just give you a bunch of graphs and you just have to pick the correct one. Alright, so then the last page is solving these inequalities. And remember, there was only one rule that we had, and then the directions say to graph the solution set as well. There was only one rule that we had, and that was if we multiply or divide by a negative number, then the sense of the inequality is reversed. And you're going to see the first question regarding solving inequalities on the exam will be identical to this one, where the coefficient of the variable is negative. So that when you divide, okay, let me recopy it as it is, and then I'll do the division. But see, when I divide by the -5, that's when I have to reverse the sense of the inequality. And what that means is instead of pointing, instead of greater than, it becomes the opposite, less than. And so therefore we get that x is less than a negative 6. And then we could graph it. Okay, again, 0 is a reference, negative 6, somewhere to the left. Now it's strictly less than, so since there's no equal to, the endpoint is not included. And recall we indicate that on the graph by an open circle. And then less than means everything to the left. So, kind of shade in the line, indicating it's going in that half of the number line. Okay, now here's one where the variable's on both sides. And I'm going to show this two ways. Bringing the variable to the left or bringing the variable to the right. Remember, it doesn't matter. The only reason why we like to bring the variable to the right, because I know most people are comfortable bringing the variable to the left, but the only reason we bring the variable to the right is to avoid negative coefficients. But let's consider both ways. Let's say I wanted to bring it to the left side. So we start, I'm going to recopy 2x minus 7 less than or equal to 5x plus 5. If I bring the variable to the left, I'm going to subtract 5x. And remember, you can add or subtract anything you want to an inequality, and nothing changes. That inequality stays pointing in the same direction. Okay, it's just like solving equations. And then if I brought the variable to the left, I want to bring the numbers to the right, so I'm going to add 7. Bring down the negative 3x, less than or equal to 5 and 7 is 12. And now we'll divide. But again, in this case, we're dividing by a negative. So the sense of the inequality is reversed. So once again, reverse the sense of the inequality. And then that gives us that x is greater than or equal to negative 4, and we can graph the solution set. Now if we bring it to the right side, where the coefficient of the variable is greater, we're going to get the same answer, but it won't look the same initially. Okay, if I'm bringing the variable to the right, I'm subtracting 2x from both sides. And I bring down the negative 7, less than or equal to 5x minus 2x is 3x plus 5. And if I brought the variable to the right, I want to bring the numbers to the left, so we're going to subtract 5 from both sides. Again, when you do the addition or subtraction, nothing changes. And if I'm dividing by a positive number, like I'm doing here, the sense of the inequality stays the same. It's preserved, I use that term. And so then we get negative 4 is less than or equal to x, which, if you want to make sense out of it, you might consider rewriting it with the opposite perspective. That is, reading from the variable, or just switching these around, put the x on the left and the negative 4 on the right, but make sure the arrow points in the same direction, toward the negative 4. So we see x is greater than or equal to negative 4, which is the same answer that we got doing it the other way. So either way you do it, in terms of a sketch, here's 0, Here's -4, greater than or equal to means closed, endpoint included, and greater than everything to the right. And then here's a final question, this one is just to ensure that you know how to solve the general type of equation, or in this case inequality. I don't think anything exciting happens here in terms of reversing the sense of the inequality, but this shows the different steps involved in solving a general equation. First, the distribution. 5 is being multiplied by x, so 5x, plus 5 gets multiplied by 1, so plus 5. Closure of the parentheses stops the distribution, so we therefore just recopy the plus 7, recopy the inequality symbol, greater than, and distribute the 3. So 3 times x, 3x, and 3 times 2, plus 6. Make sure you put the plus in there. Closure of the parentheses again stops the distribution, and so just recopy the negative x. Alright, and there's a situation where we have more than 2 things on either side, so therefore we know we can combine like terms on either side of the inequality. And on the left, we notice 5 and 7 can be combined. The 5x we'll just have to recopy. 5 and 7 gives 12. That's going to be greater than, and then on the right, 3x minus x gives 2x. Those are the like terms, and the plus 6 we just recopy. And then from there it's our 3-step process. Variables on both sides, so we get the variable on one side. I'll choose to bring them to the left, the variables that is, by subtracting 2x from both sides. X minus 2x is 3x, bring down the plus 12, bring down the greater than, and x's go away on the right, and we bring down the 6 and tuck it right in next to the inequality. So remember, when we add or subtract to both sides of an inequality, everything stays the same. That is, the inequality stays the same. And then we're going to, since we brought the variable to the left, we're going to bring the numbers to the right. So we're subtracting 12 from both sides. Bring down the 3x, tuck it into the next to the inequality, greater than 6 minus 12 is negative 6. And then finally the division. And we're dividing by 3, which is a positive number, so the sense of the inequality stays the same. It does not reverse. And minus 6 gets divided by 3, so x is greater than negative 2. And to the graph, here's 0 as a reference, negative 2. Strictly greater than means open, and greater than again, everything to the right. Alright, so that's the end of the review for unit test number 2. Please take advantage of the fact that it's going to be identical to what we went over, and I strongly encourage you to take the problem set as many times as necessary, and in order to take the test you have to score at least 50% on the problem set. And obviously all of the homeworks 4 through 9 should be completed as well, and then do the problem set over and over and over again. So put in time and effort and you will be rewarded. So I wish you all the best of luck on this test, and we'll look forward to the next unit.